Alright, for the second part of the lab, we're going to go through and draw some ray diagrams for some of the situations, not necessarily all of them, but some of the ones that we actually did in the lab. You see a few notes here about each diagram. We're always going to use 20 centimeters as the focal length, but there's going to be various object distances that are multiples of it, such as this first one here, which is 2.5 times the focal length. We're always going to draw the object as an arrow and make it 2 blocks tall. The whole reason for that is that's kind of in the middle here, so if the object gets smaller, it's okay. If the object gets bigger, it's okay. We'll still have space either way. You do want to use a ruler or some other straight edge here when drawing them. If you try and freehand this, you're not going to get very good results, and it might be counterintuitive and actually make it harder for you to answer the questions. And also, when we go through and actually do this on the test, you will need to use a ruler. And then we're going to fill in these image characteristics, which is something we talked about in the notes. So let's get started with this first one here. Alright, the first thing I'm going to do to start drawing these is I'm first just going to mark my focal point here, which is at 20 centimeters, and also F prime, which is that point opposite the focus, same distance, so still at 20 centimeters, but on the opposite side. I'm then going to go ahead and draw my object here at 2.5 times the focal length, or 50 centimeters, and we're going to make it 2 blocks tall. From there, I'm going to go ahead and draw my 3 rays, and as a reminder, they're posted up here. But the first ray is that parallel ray, which is going to go in parallel. Once it hits the lens, it's going to go out through the focus. The second ray is going to be that focal ray, which starts at the arrow, goes in through F prime, and when it hits, it goes out parallel. And then the third ray starts here and just goes directly through the center of the lens. And so we see that these 3 rays converge down here, so we can go ahead and draw our image of this arrow. And then we can go ahead and fill in the characteristics. And so what we'll see, this is a real image because the rays actually come together. It, of course, is inverted because it's flipped upside down, but we knew that as soon as we knew it was a real image because all real images are inverted, and it is smaller than our object. Our object was 2 blocks tall, and we see that this is a little bit less than 2 blocks tall. Moving on to our next one, same setup here. We're going to label F and F prime over here, and now it's going to be at a distance of 2 times the focal length. And so we're going to draw it here at 40 centimeters, and once again we're going to make it 2 blocks tall. We'll go ahead and draw our 3 rays here, so starting with that first ray, which goes in parallel and then out through the focus. Our second ray, which goes in through F prime and then out parallel, and our third ray, which goes directly through the center. And so what we should see is we end up getting our image right here. We can go ahead and draw it, and when we do our characteristics, we're going to see that once again it is real, it is inverted, but if we did this perfectly, we should see that the image is actually the exact same size. Okay, the object was here at 40 centimeters, 2 blocks tall. The image is here at 40 centimeters on the opposite side, also 2 blocks tall. It's just flipped upside down. Moving on to the next one, I already set up F prime and F here at 20 centimeters on either side of the lens. We're going to go ahead and put our object at 1.5 times our focal length, which would be here at 30 centimeters, 2 blocks tall once again. And we begin drawing our 3 rays. We start with in parallel, out through the focus. We do in through F prime and out parallel, and then the one that goes directly through the center. Once again, we have a real image that is inverted. This will actually be the last one that is in that situation. And in this case, it does form a bigger image. This is clearly bigger than 2 blocks tall here, and so will be a real inverted and bigger image. Moving on to our next one here, our object is going to be located at 1 times our focal length, so it's actually going to be directly on top of F prime here. So we'll go ahead and draw our rays here. So we do our first ray, which is in parallel and out through the focus. That one's not a problem. Our second ray here, though, this in parallel and out in through F prime and out parallel, we can't actually do that one in this case. That ray would go straight down here and never actually hit the lens, but that's okay. We'll just skip that ray and go on to our third ray, which is the one that goes straight through the middle. What you're going to see here is these 2 rays that are going away from the lens are parallel. Okay, it's not that they don't converge over here. Okay, we can't trace them back All right, they're just parallel light rays. They won't converge ever. And so what we have here is we have a situation where we actually have no image being formed. And if you remember from the lab, we had the same situation here. It said that the image formed at infinity, which is another way of saying the image doesn't actually form. So in this case, when we have a object distance that is 1 times the focal length, what that means is that no image will actually form from this lens. All right, so we're going to move on to our next one, and that really was the only case where no image was formed. We will continue to have images be formed by these situations, so I'm going to go ahead and draw my first arrow there, and then we'll go ahead and draw my 3 rays. So the first ray goes in parallel and out through the focus. The second ray goes in through F prime. It's a little bit weird here because F prime is down here, so what we're going to do, if you remember from the notes, we're going to start at F prime, go through the top of the object, and then go out parallel, and then our third ray still goes straight through the middle. And so what we're going to see is over here, these light rays are not going to converge, okay? So what we're going to do is we're going to go ahead and trace these light rays backwards, okay? So we're going to trace our parallel ray backwards, the one that went through the focus. We're going to trace our focal ray that came out parallel. We're going to trace that one backwards, and we're going to trace our central ray backwards. And eventually we see that these light rays converge over here. Okay, and so what image we end up getting is we end up getting a virtual image. Remember, anytime you're doing that trace back thing, it is virtual. You notice it is upright, as all virtual images should be, and it ends up being bigger than the actual object. All right, moving on to our next set. We do notice here that now, instead of dealing with convex lenses, we're dealing with concave or diverging lenses. Obviously, the shape of them is different. The other thing that's really important is the location of F and F prime. So we're still going to have 20 centimeters as our focal length, but now that focus is going to be on the left-hand side because it's a diverging lens, and that F prime point is going to be over here on the other side of the lens. We're going to start our same basic way. We'll draw our object here at 2 times the focal length, so at 40 centimeters. And we're going to go ahead and draw our 3 rays, which haven't changed, but how they look will change because we've switched these 2 locations. So we're still going to do our parallel ray, which goes in parallel and out through the focus, but instead of actually going back through this focus, it's just going to go out along a line with the focus. We're still going to have our in through F prime ray, so it's going to go in towards F prime, but it won't actually get to that point because it hits the lens first, and then it goes out parallel. And then lastly, we have our central ray. That one doesn't change. That one still just goes straight through the middle. As you'll see, these 3 rays over here do not converge, so we're going to go ahead and trace those 3 rays back. So we'll trace back our in parallel out through the focus ray, we'll trace back our in through F prime out parallel ray, and we'll trace back our straight through the middle ray and see that it converges over here. And it ultimately forms a virtual image. That's always true when we're tracing it back. Of course, it's upright, but now it's going to be smaller than our actual object. Moving on to this next one, we're now going to do 1 times the focal length once again. And if you remember from the convex or converging lens, that resulted in no image. But as you'll see, when we have a diverging lens here, or a concave lens, that's not going to be the case. So let's go ahead and draw our rays. Our first one, of course, goes in parallel and out through the focus, but we're going to do it on this line with the focus. Our second ray goes in towards F prime, but once it hits this lens here, it bends and goes parallel. And our third ray goes straight through the center. We see once again that we don't have convergence of our rays over here, so we will be tracing those rays back. So we'll trace back each of our 3 light rays, and we find that they end up converging right around here and forming a virtual, upright, and smaller image. Moving on to our final one here. We are going to be at half the focal length, so 10 centimeters. Same setup as before. We'll go ahead and draw our 3 rays. So the one goes in parallel and out through that line with the focus. The second goes in towards F prime, but when it hits, it bends and goes parallel. And the third one goes directly through the center. We'll go ahead and trace those back, and we find that those 3 light rays converge back over here. And so that will form an image that is virtual, upright, and obviously much smaller than our object.